Thank you. Welcome, everybody, and thank you for attending today's webinar on unique brick architecture with our Business Development Manager, Jeff Patterson. My name is Brian Yansak, and I am the Design Studio and Events Coordinator for Glen-Gery. During the presentation, you will notice the Q&A function at the bottom of your screen. Please feel free to submit any questions throughout the presentation, and they will be answered at its conclusion by Jeff. Your attendance will be marked, and we ask that you stay on for the duration of the presentation in order to receive credit. Everyone attending the duration of the course will be receiving a certificate of completion within the next few business days, and those who provided their AIA number during registration will be submitted for AIA credit as well. If you are participating today but did not register and wish to receive credit for AIA, please email events@glengery.com, that is events@glengery.com, with your information, and I'll be happy to make that happen for you. Today's session is also being recorded, and a link for you to access it will be provided within your certificate of completion. I would now like to introduce our speaker today, Jeff Patterson, a graduate of Iowa State University with degrees in finance and communication. Jeff is a 20-year veteran of the masonry industry. He began his work in the industry as an executive director of the Masonry Institute of Iowa. For the past 17 years, he has served as a residential and architectural sales manager for Glen-Gery in the Des Moines metro area. In 2019, he became a manager of business development in the surrounding 5-state region. And with that, I would like to turn it over to Jeff.
Well, thank you, Brian. Today, we're going to talk about unique brick architecture. So hopefully you're all here with that in mind. This seminar is developed by the Brick Industry Association. Of course, BIA is the short term for that. And hopefully, if I were to ask for a show of hands, who's informed with Brick Institute of America tech notes and who's been on their website before, hopefully everybody would raise their hands. And if not, gobrick.com is where the Brick Industry Association's website is, gobrick.com, and it is a wealth of knowledge. Of course, Glen-Gery's website is a wealth of knowledge as well, and there are many, many people in our organization that are here to help you be successful and help you with information. So please just reach out to anyone in our organization, myself or Brian as well. We're all here for you. So this seminar series was really hot and heavy through April and June of 2020, now almost a year ago. But it's just a message to show you how many seminars we have. We can bring these seminars to you, to your firm privately, and they're recorded as well. So we are here, and we've got a whole lot of resources for you. This is our website today. Of course, you can see unique brick architecture. And then there's 2 more seminars that are coming up that are scheduled. So you can get here by just dialing up our website, Glen-Gery Brick, and then look for events and sign up. The next one, of course, is Inspirational Global Projects on June 2nd, and then Incorporating the Forgotten Thermal Benefits of Brick on June 23rd. So please check that website out, Glen-Gery, and look for our events and sign up and be a part of that as well. So thank you for your time today. Now, we start with a simple Ledges State Park monument sign, and it's a monster. It's 20 feet tall, 6 feet wide at the top. That cap is 6'4" by 2'4". It's just a real monster. And why I start with that is just to help us slow down enough to remind ourselves what we're doing. You're designing beautiful things that are going to last with masonry, last the test of time. Now, I came up on this Ledges State Park sign when the masons were all packed up. It was 5:15 on a Friday afternoon. You know, what good masons wouldn't want to be home or somewhere else just, you know, relaxing? But 5:15, they've got all their scaffolding packed up. They're just standing on the side of the road behind their trucks, looking at this beautiful sign because it's 20 feet tall and it's just gorgeous. And they were just so enamored at that moment. They were just really taken aback. And again, we've all got deadlines. We've all got challenges. We've got, you know, pressing things. Everybody's got their problems, but we got to remember what we're doing matters to people. So let's just take a moment and enjoy that. Relating to our seminar, we of course pay dues to this trade association called the Brick Institute of America. You can see their website on the bottom, gobrick.com, and there's all kinds of resources available to help you. Here's a look at one of the tech notes. This one just happens to be number 31, all about brick masonry arches. So again, please utilize the BIA website as much as you can. Today, we've got this continuing education seminar. As you heard Brian say, if you registered with your AIA number, we're going to automatically send you a follow-up and automatically deposit that learning credit on your account. If you didn't, just forward an email to events, that's EVENTS, at Glen-Gery.com with your AIA number, and Brian will take care of all that. This is a copywritten presentation. Here's the description, excuse me. So recently, there's been an interest in incorporating articulation into brickwork. To do so in brick veneer is a bit different than incorporating it into a mass masonry wall. So we'll discuss how to add articulation within the constraints of the code. We'll talk about the building code requirements and what they say about corbelling, which is the method used to incorporate texture or articulation. We'll talk about the material specifications of brick. We'll discuss elements that need to use the alternative design requirements or rational design to meet the code. And we'll discuss the relevant weatherproofing and structural considerations for anchored brick veneer with textured articulation. So here's a brief overview of the presentation. We'll start with the basics about brick units themselves and recap the types of architectural features that typically incorporate brick. Then we'll discuss the applicable code requirements and some general recommendations. There was a time when even utilitarian buildings featured ornate elements, like this former seed warehouse in Denver, or the Rumley building with its banding, strong arches, corbelled sill courses, details and accents everywhere. So the building catches the light impressively. And notice the shadow lines offering a dark contrast to the brown brick at midday. Or this ordinary dentistry building with protruding brick headers that kind of remind me of clean, nice, straight teeth. Or the former telephone company building. The independent telephone company building lives on, even if the corporation that built it doesn't. In the downtown main streets of America, beautiful brick buildings with plenty of details exist everywhere. You just have to slow down enough to see them. However, in the postmodern period, flush, smooth surfaces became more prized, exemplified by the prominence of the glass curtain wall clad skyscraper. Recent trends suggest movement away from this minimalist style with increased interest in aged or rustic-looking materials, as well as surfaces with articulation, texture, and shadow. Brick is well suited for the incorporation of texture and articulation. Despite technological advances, a brick is a handheld unit that's laid in the wall one at a time. Inherent in this process is the possibility that each brick could be laid differently than the one before it. So this statement might seem obvious, but it's also revolutionary. So once freed from the constraints of having all the brick flush or aligned, the design results can be rather creative. And the creative options are expanded when the characteristics of the brick itself are considered, like color or texture, and also varied from unit to unit. So brick is manufactured primarily from clay and shale that is formed, then fired into a kiln. Manipulations in the mix and the firing process can create a range of colors from the same material. Shown here in the kiln photo on the middle, in the center, the brick are stacked, ready to enter the kiln, and we can see the fire way down into the kiln. The stacking pattern can create the effects like these bricks shown on the bottom left. The effect described is the way the brick were stacked in the kiln, such as a cross set, face set, edge set, or flat set. So this is flashing of brick. If the material range isn't sufficient, we can mingle or mix different colors or different color ranges, which is what's being done here in the bottom right. Up to 7 different colors have been successfully mingled to give us this wall color. For an even wider array of colors, integral colors such as engobes and glazes can be used. These coatings are fused to the brick body during firing. An engobe generally looks like a natural brick finish, while a glazed finish is usually used to achieve bold colors and glossy finishes similar to those shown in the top right. We primarily use red shale, and most bricks are made from this. Some plants use buff burning clays. Some are fire clays that are typically found near coal seams, but others are canyl clays, which are found closer to the coasts and other bodies of water. Brown burning clays seem to bond with additives better than the red shales. So therefore, we use buff body clay for glazed and engobe work. Unlimited, eye-catching, vibrant colors are available with traditional glazed brick. And subtle shades of gray created with engobe coatings, which are part glaze and part clay, can give us as many colors as you'd ever want. The Texas Department of Transportation did a great job with their Amarillo Visitor Center using bands of brick that resemble the surrounding stone strata, emulating the colors of these canyon walls in their surrounding area. So the texture of the brick units and the profile of the mortar joints can be varied to create subtle shadows that will work well to create interest at the human scale compared to the overall building. The left image depicts a combination of smooth-faced brick with a V-shaped joint profile that accentuates the outline of the brick unit. Similar effect is achieved with the center with a rough textured brick with rake joints. And at the right, mortar in a similar color as the brick is used in a combination with a concave joint profile to allow the back-rolled texture of the brick to be the prominent feature. When highly textured brick units' surfaces are viewed at a distance, the distinct texture may no longer be visible, but the subtle shadows are still detectable, creating a mottled or variegated appearance to the suggested finish. A highly textured brick shown in the insert at close range appears much different when viewed from a distance of 10 feet or more. And visitors to the Waukee High School will notice as you get closer, the bottom 5 or 6 courses are a mottled texture, and then it gives way to the same brick in a velour texture. And then we have a few courses of brown or orange brick, and then each accent band goes back to the same brick with the sculpted texture, as you can see in the bottom. We can't forget that mortar is 20% of the wall. On this job, the architect specified split-face concrete block with the mortar to match the concrete block at the base of the wall. And you can see how that mortar ties in the entire wall with the 3 colors of brick. The brick in the middle, and then is a nice brown matching with that buff mortar color. And then we've got the grays and the buff brick above that. So one of my favorite buildings. Mortar joints are typically 3/8 of an inch or a 1/2 an inch wide. About 20 years ago in Kansas City, an old brick salesman was training me, and he taught me that when matching an existing brick wall, the first thing I need to do is look at the mortar. We don't think about it, but mortar is really about 20% of the wall, and mortar joints can have a significant visual impact on the wall. So as shown here, there's a variety of profiles that can be used. Concave and flush joints create a smooth appearance, while grapevine and beaded tooling imprints, they give it an additional linear detailing. So the more a mason compresses the mortar, the more resistance it's going to have to moisture. You're not limited to one joint profile in a given wall. Different mortar joint profiles can be combined in a given wall section for an increased visual effect. Frank Lloyd Wright was famous for his combination of raked bed joints with flush head joints to accentuate the horizontal elements of his designs. A similar effect is used in modern applications. Stealing a page out of Frank Lloyd Wright's design catalog, a beautiful park structure was built in Grinnell, Iowa, not far from the Louis Sullivan Bank building. The Medina Temple in Chicago was designed with raked joints with flush joints, which helps create an appearance of a large-scale Flemish bond brick masonry, laid in a running bond in a stack bond pattern. So a lot going on with that brick, but it sure illustrates the interesting mortar uses. So here's another trivia question. I'd like you to raise your hand. If you can remember the song, There Must Be 50 Ways to Leave Your Lover. So there might be 50 ways to leave your lover, but here are 6 basic ways to put a single brick unit in the wall differently. Each orientation results in a different exposed area of the face of the brick. Additional orientation that's less commonly known is sawtooth or dogtooth, where the brick unit is rotated 45 degrees to create a zigzag appearance. Historically, the rotation was 45 degrees. However, any angle can be used, as shown in the photo to the right, where the brick orientation transitions from a flush to header configuration as it approaches the building corner. The most common type of bond pattern is called the running bond, which consists of all structure brick with offsetting head joints between the courses. Most familiar with half running bond, which is 1 brick over 2. Also, we can do a third running bond, which is a king size brick or a utility brick, and a quarter running bond with a 16-inch long brick. Flemish bond alternates headers and stretcher units all in the same course, on all courses. And an English bond includes alternating courses of all stretchers and then all headers. Stack bond aligns the head joints of each course in the brick. Due to the required tight alignment, brick with closer dimensional tolerances are necessary. And we'll talk about FBX brick in just a minute. Other variations of these types combine 2 or 3 stretchers with a single header. So brick is flexible and can go in the wall however you want it to go in. Banding, also called belt courses and string courses, is often used to create horizontal emphasis. They need not project from the main plane of the wall, consisting of bands of different bond patterns and different material. Stone, cast stone, terracotta, or architectural precast concrete can be used in lieu of brick. Differential movement joints between the bands of brick and other material must be considered and might require accommodation in the details. Banding need not be limited to continuous courses. The building at the right shows the combination of short bands that were offset to create a wavy aesthetic on the wall. Here's a nice limestone band that's also in line with the sill, and a nice little glazed band that brings some interest to a larger buff monolithic wall. I like all the details going on here. These bands some are recessed. I love the herringbone pattern going on around the lights. Just a lot of beautiful things going on in a new building. This is a music building at a college. So water tables are a subset of belt courses or string courses that include projecting elements intended to deflect water away from the wall below. Most brick manufacturers consider water tables to be a standard shape and include them in their catalogs. Different types of water table shapes include bullnose, cove, ogee, and sloped shapes, which can be combined in adjacent courses. As shown in the example on the lower right, this example combines a cove shape over a bullnose. A variation on banding is a reveal. And reveals are used to create linear articulation, either vertically or horizontally, with prominent shadow lines. At the left, it illustrates horizontal reveals in a pier and the adjacent spandrels. The brick within the reveal are laid in header orientation. On the right, it depicts a pattern of horizontal reveals paired with panels of sawtooth brick. Here's a 100-year-old example of sawtooth brick in a beautiful downtown building. So twisting or warping patterns can be achieved by changing the orientation and the placement of one course compared to the adjacent courses. On the left, the orientation of the starter unit in each course changes from a stretcher to a header, and it's rotated accordingly. The custom chimney design at the right uses the same pattern throughout, but the placement was shifted 1/2 the width of the brick on each course to create a spiral. We have an AIA CEU course on special shapes, and Kevin Lindstrom, our special shapes designer, will be happy to present it for you and your firm. You can find an example of brick manufacturer special shapes catalogs on our website and on other brick manufacturers' websites. One of my favorite special shapes is called a hinge brick, as you can see in the die and on the lower right-hand corner. Hinge brick were used at every window of this private residence on the Missouri River. Here's a close-up of it, how they used it on the edges, and a little bullnose brick off to the right side of that angle that's closest to us. But hinge brick are really neat because the walls don't have to be 90 degrees. They could be any shape at all, and the hinge would accommodate that. Some more hinged brick images on this corner, and we're seeing some nice rotated chimneys up there. And of course, 2 are good, but 5 are better. So everybody needs a house with 5 custom chimneys. Coins are an ornamental accent used to accentuate the corners of a building. They can be formed from a variety of materials, similar to banding, but most often consist of brick, stone, cast stone, terracotta, or architectural precast concrete. When other materials are used with brick, the coin is often flush with the brickwork, as the difference in the material or color provides the intended emphasis. They should also be flush with the interior side of the brick, if possible. When constructing coins with brick, they often project from the main plane of the wall on both sides of the corner, similar to a corbel. The types of coins depicted here include traditional styles to the left and a modern style to the right, one with a long format brick and tapered shape, the other creating a reverse coin formed by the recess instead of the projection. Corbels, dentils, and cornices tend to occur together. A dentil is a discrete element, evenly spaced, typically rectangular. A corbel shelf or ledge formed by a projecting successive course of masonry out from the face of the wall, as you can see here in the middle. The corbel is in the field of the wall, not part of the cornice. And a cornice is essentially a continuous corbel at the top of the wall, typically grand in size with more ornamentation on a larger projection. Historic examples, we can see the small scale articulation, and it's not really a projection. In the middle, we're going to see the triangular dentil, and we certainly want to call your attention to the sheet metal copings on the 2 images on the upper right. Banding, accents, and soldier courses can certainly add a lot of visual appeal to your projects. If you've ever laid a brick, you know how hard it just can be to lay one brick in a half-running bond pattern 1/2. They're slippery, they're muddy, they don't stay where they need to stay. So masons really struggle with soldier courses. But if a mason could lay an 8-inch by 16-inch unit that's full of false joints to look like a soldier course, just imagine how much easier the mason's job just became. Or instead of a header course, what about if the mason laid one 16-inch long unit that looks like a header course? How much easier would it be to lay one brick that's 16 inches long rather than 1, 2, 3, 4, 5 different headers, maybe 6 different headers on this 16-inch long brick, all slipping and sliding around in the mud while we're trying to keep them straight as that mortar cures? How much straighter will this header course look as a finished product with faster, straighter, better, simpler? It's a real win-win for all involved. So the masonry arch is one of the oldest structural elements and the consummate example of form following function. Its structural advantage results from the fact that under a uniform load, the internal stresses are principally compressive. Because brick masonry has greater resistance to compression than tension, the masonry arch is frequently the most efficient structural element to span openings. Brick units comprising of the arch, called vissors, are generally placed in soldier or rowlock orientation and are ideally tapered in shape. When used in a veneer, arches need not be structural. Curved lintels can be used for support, as shown in the photo on the bottom left. So I apologize, but we're going to get into some heavy lifting here. So material requirements are provided by ASTM C216, which is the standard specification for facing brick. And solid masonry units are made from clay or shale. They're categorized as solid, but they don't always have to be solid. They can be up to 25% void, as you see in these images. The type of brick, type FBS, type FBA, type FBX, it talks about the dimensional tolerances. So type FBS is the default type intended for general use, and type FBX has stricter tolerances, which makes it ideal for stack bond applications. And type FBA is the least stringent. So you'll need to be aware of these loose dimensional tolerances of type FBA for certain patterns or elements, because a stack bond wall wouldn't look all that good with different sized brick, and if an FBA brick were used. So FBA brick, maybe handmade brick, maybe tumbled brick, maybe distressed brick. You know, if you're going to build your castle, why not use handmade brick? And of course, your castle needs to be right by a large body of water. So looking at FBS brick, it's the default or general use brick. They can be slightly irregular. It can be made with character, and as we can see with these soft paper cut brick, designed with soft surfaces and rough cut edges, newly extruded brick that are made to look like they're 100 years old. What would these be perfect for? Well, they'd be perfect for a beautiful little coffee shop where you're trying to create that relaxed, comfortable ambiance. Or for a young, aspiring brick salesman from Omaha, the interior of your dining room wall would be a great place for FBS brick. Well done, Mike Lund. So FBX brick are stricter. They've got beautiful, tighter dimensional tolerances. We lose some strength in stack bonded brick, and the code calls for horizontal reinforcing wire in stack bonded applications to help give us some of that strength back. So the Masonry Society Code 402602 is building code requirements and specifications. With respect to anchored masonry veneers, there are two sets of provisions: the more commonly used prescriptive requirements that most of us are familiar with, and then the alternative design requirements that permit rational design. Let's talk more about prescriptive code requirements. These are what designers are most familiar with. Brick used for anchored veneer typically have a 4-inch nominal width and actual measurements of 3.5 inches to 3 5/8 inches. The minimum veneer thickness is 2 5/8 inches. Because of this requirement, all brick orientations might not be feasible for anchored veneer. If the brick height is less than 2 5/8 inches, bond patterns using sailor and rowlock stretcher configurations won't work. While the Masonry Code doesn't indicate a maximum thickness for anchored veneer, the upper bound is generally accepted to be about 5 inches deep, based on limits from our legacy building codes. For the purposes of the code, the only bond patterns considered are running bond or non-running bond. To qualify as a running bond, a minimum overlap of a 1/4 unit length is needed. In this context, Non-running bond does not refer to patterns such as Flemish or English bond. It refers to patterns like stack bond or basket weave, where head joints of adjacent courses align. Because of the alignment of the head joints, maybe wire reinforcing is a good idea to ensure that wall stays together. The type of veneer tie used will vary based on the backing material and the dimension of the airspace in the drainage cavity, with a minimum airspace of 1 inch, with 2 inches being preferred. The maximum airspace is permitted is 6 5/8 inches. In the case of stud walls, the cavity is measured from the face of the stud, not the sheathing. Adjustable ties are most commonly used as a veneer tie. Veneer ties generally consist of sheet metal parts, wire parts, or a combination of both. And sheet metal parts must be a minimum of 0.06 inches thick. When the airspace is between 4 5/8 and 6 5/8 inches, higher strength or heavier grade ties are needed. TMS 402 talks about the requirements for these heavier gauge ties in more detail. So one veneer tie must be installed for each 2 2/3 square feet of a wall area, with a maximum spacing of 32 inches horizontally and 25 inches vertically. So if you do the math, you'll notice that the ties are spaced at 32 by 25, and the area per tie will exceed 2.67 square feet. So these dimensions are provided to give placement options on the stud walls, since you shouldn't be fastening ties to anything other than stud walls. Cases with high wind, example is above 40 pounds per square foot of design pressure. The TMS 402 describes additional requirements needed to be met. As we discussed at the beginning of the section, the code includes both prescriptive and alternative design requirements. The prescriptive code doesn't apply in all cases, and that's the nature of prescriptive requirements. They cover the simplest and most common cases and are based on certain assumptions for their use. Cases that do not meet the assumptions inherent in the prescriptive requirements must be designed per the alternative design requirements. These include cases with high wind, where the average roof height is over 60 feet and the cavity exceeds 6 5/8 inches. Now we get into the specific code provisions that we'll use to incorporate texture into brickwork. The process of corbelling is used to construct projections and recesses in brickwork. It involves shifting successive courses of brickwork outward or inward from the main plane of the wall. For the purpose of the discussion today, only non-load-bearing corbels or corbelled elements are going to be discussed due to the focus of anchored masonry veneer. So as you can see by the formula, really 1/3 of the width of the brick is allowed to corbel over. If you're using brick with core holes, keep in mind that the brick core hole might be as close as 5/8 of an inch. Therefore, the best rule of thumb is corbel 1/2 inch or less. However, these corbelling limits exist, and with solid units, it's not a problem. So this is a multi-wife mass wall, and these are the limits on corbelling mass walls. General recommendations. These are the things you want to consider to incorporate into the contract documents. Most important is to provide extra direction in the design intent. Don't expect the mason just to figure it out. Involve other design and construction team members early in the process and as it's appropriate, and account for it in your budgets and scheduling. There's no reason not to get a structural engineer involved, because likely core-build elements will not conform to the prescriptive code requirements. Engineering will be expected. If it's addressed early enough, the structural engineer may be able to help in other support areas. For the detail of the building corners and the window jambs on this project, the architect prepared color-coded drawings to assist in the construction of mock-ups and the final product. They identified cut units, uncored units, and the 2 special shapes on the project. Because the longest projections occurred in the direction of the brick veneer length instead of the width, this detail would likely be completed with the prescriptive code requirements. So here's some extra direction information that an architect added in just a couple different projects. What I like about this, it calls out, we need a solid brick, no holes. It makes it clear for everyone. A mason sometimes is tempted just to try to use a brick with core holes, but nope, it's called out on the drawings and everybody is certain we need solid brick there. So articulating 16-inch long brick, it was a real fun exercise on a big project that won a Brick Award recently from the Brick Institute of America. It turned out to be gorgeous, and the shadow lines are just beautiful. It was a fun project to be involved in. It was a big project, and so they wanted to do something to break up the size of the building, and that articulation is just breathtaking in real life. So in the case of the project shown on the left, the mason's suggestion was to use temporary placeholders for the projecting units, allowing the wall construction to proceed efficiently without extensive temporary shoring. The projecting units were added after the brick portion of the facade was complete. On the project on the right, a dry fit mock-up was used to determine how the wall would be built. In the final product, brick without core holes were used. As discussed previously, solid brick are permitted to contain cores or frogs. However, for textured brickwork, it's recommended to use brick without any cores or frogs, which need to be explicitly specified. The reason we want no cores or frogs is because a third of the unit thickness for a 4-inch nominal brick is about 1.33 inches. And as we mentioned earlier, cored brick can be 3/4 of an inch from the edge distance of the core. So we'd hate to see those core holes, and they might fill up with water in cold climates. One of my favorite examples of this is Smoky Row Coffee House. As you can see on the top, there is nothing overhanging. There's nothing protecting this brick. Yeah, there is a little awning, but it misses. We're going to look primarily at this left corner, left of the entrance. It's solid brick. It's been there for over 100 years, as this building's been repurposed now into a coffee shop. But the solid brick have stood the test of time and not needed any replacement. Maybe they've needed a little mortar over 100 years, but they've really held up well. So the brick veneer assembly that provides the maximum water resistance is flush brickwork. Only one face is exposed to the water, and it sheds on a vertical surface. So any projecting unit or element where we have multiple brick faces exposed to the temperature extremes of moisture and the environment, we certainly need to increase the environmental exposure. It causes water to get in there if that snow is sitting there and then it melts. So horizontal projections can collect standing water in snow, subjecting the units below the mortar joints and the surrounding area to prolonged contact with moisture. So the increased exposure and the increased risk of water ingress is inherent in constructing brickwork with projecting and recessed features. So maybe this is an option where we want to see a sealer applied, and it needs to be a breathable sealer. Or maybe this building will just have to be maintained and tuck pointed a little bit more often. But whatever the case, it's definitely a stunning building. When we create articulation, it created the articulation on the exterior. What really happens to the interior plane? So it's recommended to trim back the units where possible, keeping in mind that the minimum thickness of a brick needs to be 2 5/8 inches. As an alternative to trimming, we might be tempted to install a mortar wash, but that's not recommended because that mortar might just hold more moisture in it on the inside of the wall. So the next thing that we're going to look at are some examples. The first set of examples will be projects that were created within the PCR. So the variations in color, unit texture, and the bond pattern can easily be integrated into the traditional anchored brick veneer while staying within the prescriptive code requirements. In the photo on the left, the diagonal or diamond-shaped formation is called a diaper pattern. In the photo on the right, brick of different colors were combined on a larger scale to create a color block effect. And designs need not be limited to traditional patterns. Modern modeling software can treat each brick unit as a pixel for limitless options. This nondescript garage is in St. Louis Park, Minnesota, just right along a nice interstate. What I love about it is that it's a nondescript garage, but with a little design, a beautiful blue glazed brick was inserted in the middle of this diaper pattern, and making the wall interesting, the brick out here at this rain gutter were corbelled out from the surface. So I love just seeing that wall, and I think all the commuters that move from downtown Minneapolis to the suburbs also enjoy looking at it. It's a local landmark for me. So here are some additional examples of variation created within flush brickwork. The Alice Cook building uses multiple sizes and shapes to create a bond pattern similar to an ashlar stone. In the Boiling building, vertical piers of heavy textured units are used. Banded spandrels using brick in a sawtooth soldier configuration with an offset between the courses makes it very interesting. In the top right, we're using banding with a focus on color. In the bottom right, a combination of bond pattern and color is used. So the example is a school where the same field brick was used throughout, but each wing had a different color used in the basket weave pattern. Projections up to a certain dimension are permitted within the prescriptive code requirements. A good way to start incorporating projections is to start with the bond patterns that include brick in header orientation. And in the tan brick in the middle on the lower area, for this design, the main portion of the wall is laid in a running bond. The area with the projections is laid with bond, running bond, and Flemish bond. One course of Flemish bond alternates with a course of running bond, with each header unit in the Flemish bond courses projecting the same dimension from the main plane of the wall. And in the red brick image on the top, the entire wall was laid with Flemish bond. However, the amount of header unit projections is varied from flush to several inches to create this pattern that we can see. And the tall wall on the far right, the entire wall is laid in a running bond pattern. And instead of projecting a brick in a header configuration, a stretcher unit is projected. On the lower left, we see subtle corbel details used to create an accent band on the building. Long projections trigger the use of the ADR. So this example incorporates a combination of different units, textures, and the projecting units to create this effect, which can be achieved using the prescriptive code requirements. The corbelling rules can also be used to create recess detailing. A combination of running bond and Flemish bond is used on the facade, with the overall inset area in a Flemish bond incorporated these recessed headers for additional relief. The effect can be achieved using the prescriptive code requirements. As discussed with projecting units, deep recesses will trigger the alternative design requirements. So here's a special shape made just to lay in that wall and to make it easy for the mason. And here's a number of special shapes. So special shapes are a tool that can be used to create interest in the design features. They can be used to construct forms that wouldn't be feasible as part of the typical brick masonry construction, as shown on the right in the rounded facade of this London mixed-use project. Here, the verticals are simply curved piers and are not subjected to the corbelling requirements. Depending on the bearing of the units and the dimensional projections, if needed, the alternative design requirements would only apply at the spandrels. In this case, the special shape units were used to increase constructability. Here, a Norman-sized brick with a false joint was used with two different color finishes on the same unit. And here's another example that incorporates a special shape to a great effect. For this project, a square 8x8 brick was used. 8 variations of the brick were created, each with a different false joint pattern. So it was laid in a typical running bond conforming to the PCR, but results a beautiful appearance of an irregularly bonded pattern. Now we'll move on to some examples that use the alternative design to comply with TMS 402. So the primary aspect of the ADR is that it distinguishes it from the PCR, is that engineering analysis is required. So the most straightforward use of this alternative design requirement is a case in which projections of individual units exceed the limits in the prescriptive corbelling requirements. In this type of situation, you may only need extra ties or stronger ties, but the engineering evaluation needs to be performed. So heavier gauge ties and strap anchors and stone anchors can be used in this application. Designed by Kennedy and Volich, this project is a reclad of an existing building on the Harvard University campus. A multi-directional sloped and corbelled feature wall was designed for the location above the entrance. Slope cold-formed steel framing was used as the backing, and an engineered tie system was developed to anchor the corbelled brick to the backing. The anchors, rather than relying on the bond within the mortar joint, engaged the brick through the dowels inserted in the custom drilled holes to ensure that none of these bricks are going to fall on any of the students. A brick-faced precast concrete panel was used on the soffit above the entrance. As designed by PLY Plus, this chapel is an addition to an existing hospital in Michigan. For the project, a mix of bond patterns was used, from typical stretcher running bond to an intricate detail that included a feature in which the square corner at the base of the wall was transitioned to a curved corner at the top of the wall. Brick units were rotated in opposite directions in alternative unit courses within the curved areas. No brick cut were used to create the effects in these areas. All the brick installed were solid units without cores or frogs. And designed by system architects, this project is located in the historic neighborhood of Tribeca West in New York City, where the intent was to convert an existing 3-story commercial building into a residence. The facade was constructed of double wide reinforced masonry walls, 4 stories tall, articulated with various corbels and core-to-core. Each fold created a pocket to receive reinforcing steel and grout, and mathematical formulas were used to generate the optimal coursing patterns. So far, we've talked about hand-laid and anchored brick veneer. Brick-faced architectural precast concrete is an alternative option to achieving interesting effects, particularly deep corbelling effects that would be difficult or time-consuming to achieve. Each architectural precast concrete panel and its connectors are designed by a subcontractor, so it's delegated design. Shop drawing, development, and review are required, but a lot of possibilities are out there in the precast world. So perforated brickwork is also known as a screen wall or pierced brickwork or hit and miss brickwork. It's characterized by regularly spaced or randomly spaced openings within the bond pattern of the brickwork. The popularity of this brickwork style has increased in recent years, expanding far beyond its previous role in garden walls and utility areas. A single width of perforated brick will have a limited span length. Generally, reinforcing is integrated into the system to increase span length and maintain integrity. Where solid brands of brick are present, these are optimal locations for reinforcing placement. There's also been some success with integrating vertical reinforcing bars through drilled holes in the overlapping zone between the units, as shown in the photo on the right. The Student Center at the LSE is often used as an inspirational example. It's got a wide swaths of perforated brick spanning across windows. The perf brick appears unsupported, but anchorage is present. It's concealed behind the overlap zone of the brick. Structural steel tubes called windposts were fabricated to match the width of the brick and allow the window mullions. The windposts attach to the structure and provide a substrate for the brick ties attachments. So we'll talk about the building code requirements and what they say about corbelling. Just as a review, TMS 402, typically we've got a 4-inch nominal width with brick, and we need a minimum of 1-inch cavity with 2 inches being recommended. The maximum airspace is 6 5/8 from the face of the stud, and additional engineering and additional anchors need to be used when we're from 4 5/8 to 6 5/8. We talked about two-part wall ties being used every 2.67 square feet, and we talked about the alternative design requirements. So we also want to be talking about the material specifications of the brick. And we reviewed type FBA, type FBS, and type FBX, which is the most strict, tightest guidelines. And grade severe SW, severe weather brick, is generally what all North American producers are making these days. And also, maybe we want to use solid brick or brick pavers in a wall. We also wanted to determine design elements that require the use of rational design codes. And so we talked about corbelling in line with the limits set forth in TMS 420. We talked about proper wall ties and special brick shapes as well. Again, we talked about all the resources available at our BIA website, gobrick.com. And here's a look at the code requirement publication, TMS 402. So in summary, the Masonry Code provides 2 sets of requirements for anchored brick veneer: prescriptive code requirements and alternative design requirements for cases where the prescriptive requirements can't be used or they just don't apply. Brick design used in the PCR can incorporate variations in color, texture, orientation, bond pattern, as well as features including some projections. The ADR allow for the design of larger projections and create features to comply with the code. Notice that the examples shown all took advantage of the technology such as digital modeling, as well as heavy collaboration between the architect, the engineer, and the contractor to achieve the final result. On that note, I encourage you to befriend a structural engineer and a mason and see what types of unique brickwork you can achieve. So now, questions. And Megan writes, for the brick screens, is it recommended to have the brick shape made with the hole included for vertical reinforcement or to drill the brick on site? And that's a great question. There are probably 50 different brick manufacturers in North America. That number is getting smaller all the time, but really it's a function of the clay, it's a function of the capabilities of each brick plant, and that's where this heavy collaboration is going to come into play and really be the right answer. I don't have the right answer. It just depends. Clays are different. Brick plants' capabilities are different. Start asking questions. Thank you. Great question. Please, at any time, if there are questions, please just type them in. I'll keep an eye on that Q&A feature. Since we've got a couple minutes to go until our hour is up, I'd just love to take a moment to tell you a little bit about Brickworks. Okay, here we go. There was a follow-up question here, and this question is, the follow-up is, I'm concerned about the field drilling of the brick in these conditions. Yes, it is the mason's skill. And again, that's a combination of, does the brick plant and their product lend itself to a special shape where maybe it could be preformed into the brick. So brick screen walls are beautiful. Thank you for being interested in that question. Yeah, can the mason do it easier, better, cheaper, faster? Can the brick plant do it better, cheaper, faster? It's just one of those questions. It depends. So thank you. Good question. And again, if there are more questions, please type them in. We're here for you. But in lieu of questions, a little bit about our company. So Brickworks, Brickworks is an Australian company that purchased Glen-Gery and several other companies in 2019 and 2020. I'm sorry, we were purchased in 2018. Amazing things have been happening for us, and I can't imagine without Brickworks' guidance and infusion of investment that we'd be in the position we're in today. We are a brick company that specializes in the Midwest and the Upper East Coast. We've got our 9 plants, with the Cynthiana plant being a stone plant. Our corporate headquarters is in our Philadelphia design studio, and the rest of our corporate headquarters is in Wyomissing, Pennsylvania. So there's a little footprint of who we are, where we're at, the kind of products we make. We make glazed clay coats and on-go brick. We make handmade brick. We make manufactured stone. We are a partner of Creative Minds. We make the Landmark brand. Molded brick are something that we have 4 different plants that can make and do make often. It's specifically East Coast applications, but molded brick are just beautiful in the fact that they look like handmade brick, and they just have a lot more character. That the wall that's featured, that is a brick project with our molded brick. We have a lot of thin brick capabilities. We cut molded brick, as you can see on the right, and we do extrude split tile as thin brick as well in some of our plants. Any brick you want, we can make it as a thin brick as well as a full bed brick, so you can match. Maybe an interior project can be thin brick. But our primary business is extruded brick. As you can see, we've got all kinds of textures, all kinds of shapes, and all kinds of colors. We do a number of pavers as well, and we make more than 1 million special shapes a year. Got a beautiful catalog on our website, and again, the offer is out there. If any of our 24 seminars that you can see and read about on our website are available to you, but Kevin Lindstrom would be glad to deliver a special shapes seminar to your firm at any time. We also have a division that specializes in what's behind the wall. And we want to review your Division 4. We want to be a resource for you, because getting it right and making sure that all the wall products behind the brick wall are compatible, that they won't melt when they come in contact with each other, that they'll perform. We want to help you make sure they perform. So a couple of international products that are with us, this long formatted brick called Corso. It's extremely beautiful. It's made in Spain, and it's sitting in stock here. Long format brick is just very elegant and unique. We also have Venetian glass brick, which is beautiful, and La Paloma in a full bed and a thin brick version, the whitest whites, the blackest blacks, and this beautiful flashed gunmetal in between. You can read more about that on our website. We also have a facade system. This is Terrasod, comes in 16 beautiful colors, and is just a unique, beautiful system. But most importantly, Glen-Gery and Brickworks, our values are that we care, that we collaborate, that we exceed expectations and requirements, that we are innovative, and that we have integrity, and that we have a leadership position in our industry. So we want to be there, and we want to help you. We've got one more question, a random question, okay? There are new products available that replicate the size and vitrification of the oldest street pavers. Modern pavers are fired at required temperatures to achieve vitrification. Yes, let me just make sure I read that correctly. are there new products available that replicate the size and vitrification of old street pavers? Well, old street pavers are sometimes formed. They're beautiful, and yes, we have a number of products that can be tumbled to look like used, beat up street pavers. Yes, we make modern pavers. So it's kind of difficult for me to answer that random question immediately. Again, let's contact our favorite Glen-Gery representatives and ask that question and let them provide some things. We're here to help. It's my best answer. Speaking of resources, let's see. I wouldn't be fair if I didn't mention the International Masonry Institute and their website and all of their resources. There are all kinds of drawings, all kinds of suggested walls, all kinds of detailing. IMI is sponsored by union bricklayers and their union dues. So it's a great resource for all of us in the community. And if you want to know more, please go to imi.org to find more about their website. Similar to our brick industry website at gobrick.com, there's just a ton of resources to help you do masonry right and to help educate you. So we want to be there. We want to support you. As we grind down to the hour, I just want to show you again some of my favorite shots. The inlaid black herringbone pattern and the corbelling of this are just gorgeous. Big bold patterns. If you're going to do a children's orthodontic clinic, what do you want? You want some big bold patterns. Why not? This old brick building's been just one of my favorite shots for a long time. And then the final shots, some nice header courses in a modern building and a nice inset in this beautiful little facade and some storefronts. Brick we're proud of, and some nice blocking of different colors. Some nice banding. So with that brings us to the top of the hour, and I see a couple more questions. Okay. Question is, for historic preservation, what do you recommend for reinstating historic brick that has been painted? Painted surfaces, there are two manufacturers. One is Proseco and one is Dietrich. You can get to the Dietrich stuff by going to the Homan Bernard website, h-b.com. Homan Bernard, look for their Dietrich paint strippers. Both of these companies have wonderful paint strippers that you just wet the wall, you spray this on, and you leave it for 5 or 10 minutes, and you come back and you spray it off. The paint strippers are going to attack the paint, and they're not going to hurt the brick. So there's two answers. One, Homan & Bernard's website. The second one, Proseco.com, Prosoco.com. Both of those places have great tech web services for you. That away, perfect. Yes, paint can be removed or cleaned without damaging the brick. Again, those two sources can help. Also, not sandblasting, but dry ice blasting can hit paint, freeze it, and then knock it off as it changes its structure. So dry ice blasting can also help. The next question is, are you seeing increased integration of brick walls with other exterior cladding systems, such as glass or curtain walls? What should one be aware of when designing those walls? So I can specifically speak on designing brick walls, and of course we would need to have a subsurface that has an L/600 backing. When it comes to glass and curtain walls, I'll admit I'm out kicking my coverage, so I refer you to specific glass and curtain wall people that can answer that. And that is the extent of our questions so far. All right. Again, Glen-Gery is here to help in any way we can. We've reached our hour, so I thank you for your time. Our website is glen-gery.com. And again, anybody who might have just jumped on through a link without having their AIA number, please email events@glen-gery.com, spelled EVENTS at GLENGERY.com. And please keep checking on our website, get signed up for those upcoming seminars. They're fantastic. And I appreciate everyone's time, and get out there and make something happen today. Every day I look at my job as solving 99 problems, and I'm sure your jobs are as similar. So good luck with the remaining questions and problems out there that you're addressing. And please rely on the support of the masonry industry. Again, Glen-Gery.com's got a lot of support. GoBrick.com is the Brick Industry Association website, and IMI.org, O-R-G, is the International Masonry Institute website. So lots of support, lots of help. We're there to help you be successful. Please let us know how. Thank you.